All right. So on Wednesday, believe you all covered Transcribe, and you were mostly working with Transcribe from the command line interface, right?
Mix of Terraform and the command line interface.
Okay, cool. So you guys already did start with Terraform on okay. Well, I know you guys started with Terraform at the start of the week, but with Transcribe in particular, and realize you had. But let's back up a bit. I'm going to switch up the labs today, or actually, I'm going to demo a variation on the second lab. It's going to be a lot quicker, just talking about the difference between locals and variables. And if we haven't talked about variables too much already, basically, just as the name implies, it's a way to provide different values to different blocks of code in your Terraform files. Now, when you have variables defined, there are multiple ways to modify them, aside from just modifying them straight within the Terraform file itself. You could actually also change them during runtime. So you could override the variables that you have defined in many different ways. And let's see how that's done. So I'm going to make a fresh project here. Let's go to colors, number two, and let's make a Terraform file, main.tf. And we're just going to create some very simple boilerplate. I won't even call it boilerplate, just a basic resource. So let's call this uh, index, something along those lines. Let's make it an HTML, or sorry, no, we want local file, and we're going to name it index here. Whoops. And we're going to add a few definitions. I'm going to give it a file name, and we're going to specify the content. And it's going to be a very simple HTML file. Now, here, I could set a variable. And so if I do var dot color, well, let's leave that there for now and say hello world. Let's see what's wrong with my syntax. Okay, I'm missing semicolon. No, I don't want that. It's an autocomplete for me. Missing that. And now let's give it a variable for color. Looks like there's still
Is it the double quotes at the beginning of your H1 tag?
good catch. So let's add that, and let's also somewhere else that it's
Does
what was that?
I don't know. I was just trying to figure it out.
Okay. Let's see what it says.
Color. Style equals in quotes color colon space.
Well, let's see what happens if we try to run this. So let's do a Terraform init. Now that we've initialized, we should be able to plan. And it's telling me I'm missing something. The argument file name is required, but no definition found. Oh, there we go. There's one thing. File name, not file. Let's try again. And now it looks like it's good to go. I'm still wondering why my syntax highlighter is complaining about that. So let me try a Terraform validate. Says it looks good, so let's trust it and let's go ahead and apply. Well, if I do apply by itself, it's going to ask me, it's going to prompt me for confirmation. I'll go ahead and say yes, and it's been created. And this is a local file that we're making, right? So it's going to show up down here. And if I use open, I can open up my browser. All right. Hello, world. Let's see. Let's actually have that here.
So it's like your linter is complaining, but it looks like it's working, right?
Yeah, exactly. It's just the CSS. It's a CSS rule. Yeah, I'm not sure what it's complaining about exactly. Let's see if, what is it? Copilot has anything to say, or Claude, I guess. And syntax highlighting is interpreting blah, 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 blah. False error with embedded variable syntax. Okay, so nothing to worry about. Right, so now that we have this up, we can start to modify it, right? Because we're working with variables. And even if we define it as having these values inside of the var file, if I do a Terraform apply, but pass in a variable, so let's say, what is it? Color equals, let's say blue. What's wrong with my syntax here? Oh, I had a dash, I see. Color equals blue. It's again prompting me, so let me say yes. And if we refresh, it's changed. Now, if I run a Terraform apply again, this time with auto approve so it doesn't prompt me, we see that the value reverts back to red. So basically, because I'm not passing in variable along with the apply command, it's reverting to whatever value is defined in the Terraform file itself. So that's one way to override variables during runtime. When you're, let's say, maybe automating the release of something, you could explicitly add that variable uh, argument to whatever is automating the running of the apply command, right? So that might not be the best practice, um, but it could be useful in certain scenarios, right? And I say it might not be the best practice because it's not really intended to be a permanent change. If you were going to change the color, you might as well go to the Terraform file itself and update it. Let's look at another way of updating variables, and that's going to be through, let's see, what does the lab say? Talks about, right, TF vars. So let's make a TF vars file. So let's say colors.tf vars, and let's give it a value of what do I have here? Let's also give it size. Let's give it another variable. Font size equals, whoops, and let's make another variable. It's 120. Now, if I create a colors, I don't like that name anymore, actually. Let's say, and move that, just call it new, a little more clear, um, and add a value equals, I don't know, 500. And we go back to the index file. Let's do a Terraform apply with the TF vars file passed in. So we're going to be using dash var dash file with the name of the file. So new vars inside of quotes, vars, got my auto approve. And if I hit refresh, looks like it's not applying because something's wrong with my syntax probably. Let's see here. Let me just do a quick cat of colors. What did I have earlier? New.tf vars. Whoops. I might be missing my double quotes. Let's also change the color. It's orange. Save. Now let's try the apply again. Auto and change that, but did not change the color. So something's wrong with something here. Font size matched here. I think I might know what it is. Or I might not. Let's see. Actually, I don't know if that's going to matter. I don't think it's going to matter. Oh, there it is. There it is. I'm missing PX. PX for pixels. Oh, I guess that's not it. Um, oh, let's see. Is it this? I don't think it's that. Okay, cool. There it is. So I had one, I'd forgotten the closing quote here. I had it here before where it was before I added the second variable. I just had to move it. Now that it's updated again, if we just do a Terraform apply with, well, we changed the variable. So even if we did this without anything, without any parameter, it should still be right, whatever is set inside of the Terraform file itself. So these essentially are just runtime variables again. It's just another way of passing in um, variables that run during a particular apply. Okay, and let's just do one more thing. We could also set variables to, let's say, a message. So if we do variable dot message, and create a block for that. And let's apply, and we have new text. Cool. Okay. That's environment variables in a nutshell. Oh yeah, let's actually show this as well. So this you might start to run into when you're working with something like, I was about to say React, but that might not be the best example. Um, GitHub Actions. When we get to the GitHub Actions portion, well, we might even run into it before then, but to continue that line of thinking, and when we get to the GitHub Actions portions, we will be using GitHub Actions to automate the provisioning of resources. So creating Terraform files and then running them through GitHub Actions. And we could use things like TF variables to create variations. Like, let's say maybe you want to have a development build locally, but when you push to an EC2 for staging or production, you may want to change a few things. Like maybe you change the host value for SQL database. And we could do that through these variables. Now, notice the syntax in the front, TF-var. If I create a .env file, so .env, and let's add some variables. If I just do font size by itself, like we did down here in the TF-vars, let's see what happens. Just make it something all modest. Source.env. It's an env file, so I'll have to source it. Now, first off, it can't find it. So let me get rid of these. Shell is particular about spaces around the equal sign. I refresh, we see that nothing has happened. Now, if I add TF vars or TF-var, I don't know if it's case sensitive, and I do, oh, I have to do a Terraform apply. That might be why I didn't apply. Oh, and I want to not pass this in. Okay, let's also change the message to just back to hello world. Terraform apply, auto approve, refresh. Oh, might help if I sourced it first, right? Oh, it's not even changing. Let's see, what am I missing?
It, where in the Terraform files are you pulling those environment variables?
It's actually,
Because go back to the main.tf.
mhm. Oh wait, wrong one. Code main.tf. Mhm.
Because I don't understand. Right now, it's just pulling from this file. Yeah, string red, font size 120, and it's using hello from Terraform. So it's using what's in this file right now, right?
Exactly.
Don't we somewhere in this file need to tell it that instead of using the default values you have hard coded in there to pull from the env file? Or no?
Actually, it wouldn't be the sorry, it wouldn't be inside of the Terraform file because basically what we're trying to do here is we're like trying to override the values inside, right? And we've done that by just passing in var or var file during the apply command. But we could also do this by loading up these environment variables essentially in our environment, the same environment that's going to run the Terraform apply. And I think maybe I'm missing this Terraform plan here. So let's try the Terraform plan. It says no changes, but it might just be because it's only environment variables that we're changing. Let's try the Terraform apply again. And still no luck. Let me try sourcing the env again.
Are we working with a TF-vars file, Julius, or we're
Now,
still just working with main TF?
let's see. Maybe if I was tracking the colors better. Um, let's do black for main TF. Let's try Terraform apply. Okay, and it's back to black. How did I do this earlier? Let's see. ls colors s a. Yeah, I had .env file there. TF bar. So what's different? Oh, maybe that's it. No, doesn't seem right. It should still be export. Um, let's just try it from terminal real quick, and then plan, Terraform, apply. So this worked inside a terminal. Why was it not working in the env file though? That's that's throwing me off. So okay, as we see, if we do load the environment variable in our session, in our environment, in our shell right now, that will override the values inside of main.tf.
Load it as in you source.env.
Exactly, exactly. Now, it wasn't working when I did source.env, so I just ran export manually from shell. Um, so let's see if we can get it to work. Let's see what is going on here. Let me source this .env file. Sourcing this should be running these exports, which will load them into our environment. And if we do the Terraform plan and apply, it should work. It's throwing me off. I don't know why it's, yeah,
Yeah, according to the internet, you have to have the export in front of them.
okay. Let's see. Let's try unsetting them first. Oops. Even though I don't really think this should matter if we're trying to overwrite them. We do that, then we Terraform file approve.
Is your are you in colors TAC 2, but your environment files in colors?
Yeah, good catch. All right. Okay, cool. So let's thank you for that. Let's change what we have here. Let's source that and let's plan. Now we get the result we want. It's telling us that we'll have a new hello world. Okay. So we saw three ways to overwrite the variables that are defined inside of your main.tf. And basically, they're all just ways to change these values during runtime. Probably a lot more handy later on when we're maybe working in some actual contexts. But this essentially should be a very visual way of seeing how this works. Let's let's see if let's see let's see if we could get locals to work. I think I was having trouble with this earlier. And one thing we could do with locals that we can't do with variables is mutations. So let's go to where it's not a main.tf. Let's create a locals block and let's see if we can get this to work. Variable. Let's see. Or actually, no, this is what I want to do. I'm going to set color here to what haven't we used yet. Uh, Pink. And I'm going to try to use this value inside of here, local dot color. Now let's do a Terraform plan. Terraform apply. Cool. It actually worked. I don't know what was going on earlier, but let's see what else we could do with this, right? If we go to, let's see, font size, and let's set this to, how did I have this earlier? Or maybe let's do 250 times 2. Terraform plan. Oh, might help if I change this to local. Terraform plan again. Terraform apply. And we see that we were able to multiply that size. Now, I think this actually should work as well with this, but maybe a better way of demoing this is dot font size. Let's see if that works. Plan looks good. And now we have a super massive hello world. So I'm just trying to think of a good way to really articulate the difference between locals and variables. Locals will override variables, as we saw. And if this was just locals by itself, we saw that it was using locals value over um, the variable font size value. And this will particularly start to come in handy when we're working with, let's say, not even necessarily modules, but maybe modules. Modules, because when we start to work with modules in Terraform, it's essentially like a class, right? You could instantiate a class, create multiple instances of it. Similar with modules in Terraform, you could reference a module with another Terraform block to essentially create a copy of it or a child version of it. And in that kind of case, I mean, you could just override it without locals anyway. Is Kim here yet? We have, maybe she could help me with a good example. No, Kim. Hey, maybe she stepped away. Okay, one way that we use locals at work is we'll have these modular Terraform templates, right? And different teams will be using the same modules, but we might want different values for certain things like team name. We would still, I think we would still be able to change the variable for that. So maybe this isn't the best example either. Now I kind of want to just look at, I'll go back to this later. I'm gonna look at something after this recording. Maybe I'll go back over this in the afternoon. Trying to like think of the use case. We could use locals to also, it seems like everything I think of we could do without locals, but I think I need to see an example up front. It's hard to think through. So let's pivot over to where were we? This lab, AWS Transcribe using Transform. So now we're going to make another project. And we're going to create some files, main.tf, variables.tf, terraform.tf vars. Oops. Let's save, and rename this to this. And let's just close all that so we don't end up working on things in the wrong directory again. I'm done with that. Maybe we could leave that for now. Okay, so what are we going to do first? We are going to set up foundational configuration. So inside of our variables file, we're going to toss in this code just to have a reusable variable for things like region, which we'll want to specify in multiple resource blocks for different resources. And inside of our terraform.tf vars, let's add these. Oops. Okay. And let's actually change this a little bit. Let's say default value is US East 2. And we're going to use the vars to overwrite that. Let's also do that. Well, actually, no, let's leave that there. Let's change this to -2. And we're going to add a provider to our main.tf. So let's go back to that main.tf and add, let's see if Copilot, nope, did not want to autocomplete. So let's just copy paste. We're going to specify the version of the provider that we want. And we're going to create some custom vocabulary. So let's save. Let's also add this block here. And let's also add a filter.
Hey, Julius.
What's up?
Um, where are we at with the lab? Because I think we did this on Wednesday.
Oh, snap, you did. Good call. Thanks. Okay, I'm looking at the wrong one.
Yeah,
But it
but
is a
did we do
prereq for today's lab.
right for the lambdas? The read ahead on today's lab adds the lambda function to it.
Ah, okay. So let's maybe blaze through it then. Is this, what's going on here? Is this like a, it looks like the same thing here. Main variables, create initial. Okay, I think it's just like a sped up
Mm-hmm.
version. It's like it's just copying, pasting everything. Right, import day 3 resources, blah, blah, blah.
Isn't the beauty of Terraform, though, that if you don't have day 3 resources, this should detect that and spin them up if set up right?
If set up right, correctly, yes. So I would want to use either a data block, or I could also port, or I could reuse that same Terraform state. So right now we don't have Terraform state saved remotely. We'll start to cover that next week. Remote backend state for Terraform is super useful when you're working in larger organizations and in groups. And in general, what's something that you really want to persist over time because it's how you essentially will be able to work in one location and then have somebody else in another location work on those same resources. But because we don't have Terraform state set up, if I try to run this Terraform apply, it's going to treat all of these resources as new resources. And if I try to create something that there could only be one instance of, like a bucket, right? Buckets need unique names. It's going to complain and throw an error at me. So let's see. Did Chad, I'm gonna assume he did, but did Chad spin everything down at the end of the lab?
I think so.
Okay. Okay, cool. So let's do this then. Let's go ahead and let's save all of this stuff. Terraform apply, auto approve. Whoops. Got to terraform init first. And let's also, oh, this is another terminal. I'm on another terminal here. Okay. So we've initialized these resources. They should have been created. We could use some command line commands to validate that. And I think there might be some in day 3 lab. Or I guess not. Oh, wait. Yep, there is actually. That's delete. I just want to look for the resources. So I want to be able to see AWS, transcribe. Yeah, let's do it this way. Let's vocabularies. I did not apply with Terraform TFR, so this should be inside of East 2. And we're going to grep for whatever I named this. AWS vocabulary, project name. I don't think I've set project name yet, did I? Okay, so it might just be blank. So let's just grep for the last part. Okay, no results. So, oh, I initialized, but I didn't apply. Whoops. Terraform apply, auto approve. Oh, I probably should have ran plan first, just so we could see what it wants to create.
Well, apply runs a plan, right? And then asks for your approval first.
Yeah. Well, I'm using auto approve, so
Oh, yep, okay.
and it looks like something has to be off because it's hanging here. So yes, let's do unrecognized remote plugin. Okay, the plan's not even complaining about anything. So why did it hang? Let's take a look at this. Have a resource for a filter, a resource for some vocabulary. I don't know what was causing it to hang. Well, oh, um, wait, no, AWS was working, so I don't think it's my credentials. Let's try that again. And while that's spinning up, let's do okay, so it's creating it. So let's do a dirt transcribe number 3. I'm going to do the same thing here, main.tf, vars.tf. Just do that for now. Let's very intentionally set this to a different space. Okay, so this is taking a while, but what I want to do is I want to copy paste all of this into main, and let's see what happens if I try to recreate it again. And let's see, going back to day 4, just to initialize. So once this is created, I'm gonna try to recreate these same resources. I don't know what's taking so long.
When I did this, it took a long time too. Like a minute
Oh,
and 40 seconds, I think, total.
okay, cool. Just have to be patient. Nice. Wow. Okay. So let's confirm. We grep for this. Oh, we're still not getting. Oh, maybe it's because no, it's a grep, so I don't think region US East 2, region US East 2. Let's not grep. Let's just all of the.
None in East.
Let's see. Okay, is something wrong with any of the syntax? Oh, we do have a project name. Okay. Oh, okay. Shoot. How do I do this again? I forget how my aliases are set up.
In
No.
your vars, what region did you use?
US East 2. I think what's happening though is I think it's pointing to the wrong AWS account. And I can't remember what I set my aliases to. WS, CPO. Those are the old ones, I guess. Let me check my Zesh real quick. Let's just grab something else like that. Did I not set those up here? Okay, I'm forgetting how I did this. I think these aliases were on my old laptop. So that means I'm gonna have to, oh wow. That means that we're gonna find another way to uh, double check our AWS credentials. So let's see. I need to look this up because I always forget. That's not too helpful because my name is probably Julius on both accounts. I think I definitely have some snippet in here for something. So let's copy that.
I just ran, sorry to interrupt, AWS list
Hmm.
or AWS transcribe list vocabularies for region US East 1.
Hmm.
And there is one that was made at about the time that you ran it. So would you check US East 1?
Sure.
So AWS space transcribe space. Yeah, there we go. Is that it?
I mean, it could be, it should be. Um, let's give it a tag. So let's see. Well, let's also just take a look at why it's not var AWS region, var semi doing anything funky. Oh, I wonder if it's because of my, I really don't think it's this. Whoops. I meant to do this. No changes. So why is it region? Oh, I see. Not actually using region. The AWS provider has region set, but these do not. Um, Hold on, that doesn't make any sense. I would think that it would still load. That matches. That's really weird. Um,
Yeah, somewhere it looks like it's picking up US East 1 or maybe defaulting to it because something's not linked up properly.
right,
Those are just my assumptions. That's because it looks like it got created in East 1.
right. That is my default for my account. Um, and is anybody else running through this lab? Like this could also be just to rule that out, just through all the possibility that somebody else made this exact.
I'm just watching.
Okay. Let me double check AWS accounts here. 4728. What was that? Yep. So that is the right account. Let's try doing the region straight up in here. I change this to US 2. Okay, so it's updating the plan. East 1.
Wh- What's hmm. When you get a chance in your main.tf, would you undo a couple times to see what was there before you hard coded US East 1? Like
Sure.
Control Z, whatever the hotkey is.
Okay.
var.aws region. No, no, that makes sense to me. Okay, never mind. Sorry.
Yeah, this is confusing.
One more thing for my sanity. Would you open up the File Explorer extension on the left-hand side,
Hmm.
like to where we can see? Because like I know we have multiple folders, and maybe we're working in the wrong variable file or something.
I checked that too. Like
You
we're,
did. Okay.
we're lined up here, but our TF vars file
Right there. It says AWS region 1. Maybe
Cool.
it's overriding it.
Yeah. So let's change that up to 2. Let's save this back as that and do a plan. And it wants to update. Okay, cool. So let's leave it at 2 for now, and let's actually go to our third project, and let's set this one to 2 as well. If I do a Terraform init, along with the Terraform plan, that might take a while. So let's leave that. If I try to, what I expect will happen is if I try to create this using Terraform apply, it's just going to go ahead and create them, and they're going to be created with different. Okay, hold on. So it says an input variable, AWS region. That's the wrong one. This is what directory am I in? The hell? I have no idea where that file came from. Okay, let's do that. Let's run that plan again. And I'm gonna grab some water real quick. My throat's parched. Dang, out of water. Energy drink will have to do. Okay, so plan 2 to add, 0 to change, 0 to destroy. Right. So if I run an apply, it should just create these new resources, right? But what if we didn't want to create new resources? What if we wanted to use these exact same ones? Well, we could do one of 2 things. We could use import or we could use a data block. Let's try it out with import first. So back to day 4. That's not the lab. Not the right lab. Wait, I guess it was. And if I go back here where I listed the vocabularies, we left it in 2. Wait, no, we left it in 1. My bad.
Yeah, so we have none in two. So one of these has to create, right?
Mhm.
If we want to. Okay.
Okay. Right. So because we left it in 1, if I do save this to 1 and run my Terraform plan again, right, it's still showing the plan because it's going to try to create it. And if that's not what I want, then we'll have to find another way to bring those in. So we could grep for the resource. And once we do, we could import that resource. Actually, I'm a little curious now. Well, let's try that first, maybe. I'm gonna go ahead and do a Terraform apply, auto approve. I'm curious if we're using the same names, what it will do. Transcribe demo security filters, that exact same name here. Shoot. Might not have. Regularity filter. So it looks like it's creating. And let's just clear that. Let's list again. What I want to see is what these names will look like if we do another list.
Yeah, I listed vocabularies and I can see the one that you're making right now or just got finished creating,
Mhm.
and the names are slightly different, so I guess it's not going to complain. So the one you made 15 minutes ago is called Transcribe Demo 2. The one you just made is just called Transcribe Demo.
Oh, dang. Okay.
And they're both in region 1, as expected.
Okay. So let's try changing the name inside of projects to transcribe demo 2. And let's plan again.
Now it's realizing that it exists already, and it says it's going to make modifications to it.
Yes, but that's also because these resources are currently in state. So let's do this first real quick. Let's go ahead and run Terraform destroy on the transcribe dash demo 1. Yes. Let's update that back to 2 and save after this is done. Did you all make lambdas on Wednesday?
No,
Okay.
unless I don't know what a lambda is.
Okay, cool.
Like an AWS lambda function?
Yes.
No, we did not do that I remember.
Okay. I definitely want to get to that. So I'm going to try to speed up through here. Let's do a Terraform plan. Okay, so now it's going to try to add 2. If I go ahead and apply, let's see what happens. Cool. So now it's throwing an error because these things already exist, right? And it can't create the exact same thing with the same name. So let's grab the name. Let's run an import. Mode 2 dash AWS vocabulary and region US East 2.
I think you're in all of this has been created in US East 1.
Right. Okay. So that's my default. So if we just do that without region, it was saying it couldn't import it because it's non-existent. Let's just list again. Let's try to copy this directly. Oh yeah, I'm missing a dash because I can't type. And let's just sanity check. Yep. Control Command F is showing the same thing. Okay. That was successful. So now if we do a Terraform plan, one to change, one to destroy, because we've only imported one of these. So if a resource exists, you could import it into your Terraform state. And you'll see next week when we do set up Terraform state that we won't have to do the import if we load up the state. And then there's another way of doing this, and that would be through the data block, right? So maybe in interest of time, let's see, what's this second one called? Sensitive filter. Let's go ahead and ask. List, llama, run. Let's see, let's try a new. I haven't had a chance to play with this much yet. Let's ask DeepSeek to convert this for us. And while waiting for that, I guess we could also just try to work our way through this. It's going to complain if my syntax is wrong, and I think my syntax is probably wrong because I'm not good at remembering these things. So, plan. Invalid data source. Convert this into a data source for me. It's still creating it as a resource. Okay. Whoops. Okay. So DeepSeek failed us. So let's try something else. Data, AWS transcribe vocabulary filter, sensitive filter. I don't need any of this, apparently. So if we get rid of all this, Terraform plan. Okay, so this cannot be used as a data resource. Let me just double check that. Oops. Yeah, it's even saying down here to import. So what would a better example be? Let's maybe look at EC2s. Here, oops. Just do a regular instance. So here's an example of what it would look like if we wanted to import an existing EC2 instance. You would just use the data keyword instead of resource, and there will probably be some variation in the syntax based on what you're trying to work with. And as we just saw here, not every resource supports data, but for a lot of the EC2 stuff that we work with, it will. VPCs are an example of what it would work with. But the alternative would be to use Terraform import. Okay, so we've covered bars and we did import. So now let's make another project, one for Lambdas. And if you're not familiar with what Lambdas are, in general, what Lambdas are in, like, let's say in a JavaScript context, they're anonymous functions. That's the syntax for them. And that's because they're called that because you don't have to name them in JavaScript, right? Like you could just do something like this. There's no name here. These are the parameters that you would pass in, and you use the uh, arrow function to specify what you want your output to be. That's what JavaScript lambdas look like. Now, generally, lambdas are, even in AWS, sort of have that same function, right? The intent is that they run without the need of, let's say, a server, not the best word, without, let's say, a persisting host to live on, right? You don't need to set up an EC2 in order to run a Lambda, and that's one of the beautiful things about it. Uh, Basically, when you call a Lambda, it's just going to like automatically spin up an ephemeral environment, and when it's done running its code, it spins back down. And we can make multiple functions with Lambdas. We can make them through the AWS console. With Lambdas, you could select various runtimes. So you get to work with different languages based on your preferences and your use case. And of course, you could also select things like the architecture. It's easy enough to make a Lambda in the console. Making it in the CLI is a little less intuitive. So let's see what that looks like. We're going to start a transcription, or I should say create a Lambda that would start a transcription. So let's call this, I'm sorry, it's getting really cluttered. Let me get rid of DeepSeek. Let's get rid of all that. Let's do start transcription.py. And we're just going to copy paste this entire thing in here. Okay, what this code does, it takes an S3 audio file and it will create a unique job name, uses your vocabulary from day 3 to understand AWS terms correctly, and it should return the job name. It should do all of that if it runs. Now, let's look at creating this locally. There's not an example here. I'm surprised there's not an example here. Maybe it's inside. Yes, the lesson. Okay, so right. Why use Lambdas? A lot of the services that we work with, like Transcribe and Poly, or I should say AI services, have a built-in way for you to interact with them, right? When we've worked with, let's say, Poly or Transcribe inside of React, we were using libraries to interact with the software development kit for AWS. And that essentially goes straight to this REST API, right? But that's a very curated manner in how you interact with an AI. Like it's got guardrails, it's got limitations. Basically, you only do the exact function that is allowed, right? With Lambdas, because we could write custom logic, we could customize our function to suit our needs, to suit our use case. There's also some other variations, like you don't necessarily have to be passing in credentials. Um, so when you're working, let's say, from the front end, if you've already got the Lambda set up, you could hit that Lambda from your front end app. You don't have to go through the additional trouble of setting up a library to interact with the AWS API. What else? Um, yeah, fan out to multiple services in one call. Standardizes behavior across environments. I guess you can make that argument. I would I would say that the REST API is also standardized across environments, but okay. Creating reusable single-purpose endpoints. I guess the keyword here is creating and allows you to, again, create so you could customize the logic to suit your needs. Those are the variations, the differences between your regular API calls and your Lambdas. Now, creating these, as we saw in console, should just be a pretty straightforward guided experience. Let's call this, I don't know, demo Lambda, create function. It'll provide you an editor in which you could use to write your code. So once this spins up, it's going to give us that editor. We could test the different things we want it to do. Sure. And it's actually a pretty decent editor. So it's already got some boilerplate code. And if we test this, well, we have to write the test first. That's how this works. So we have our code here. Let's write a test. I haven't used this in a long time. How do I pull that up? Nope. Oh, this is a new editor. Yeah, how do I write the test? Oh, there it is. Create new test events. When you create a new test event, you're going to be specifying essentially what kind of parameters you would be passing in. And these would be the same parameters you pass in if you were calling this Lambda from some external location. Right now, it doesn't really take any variable. So I think I could just save this and invoke it or demo test. If I save it, I could run it from here. I could also invoke this test straight from here. So basically, if I was ready to test it and I wasn't sure if it had all the changes I want or not, I could just invoke it here. And once I'm happy with it, I could save it and call it anytime I want from down here. Now, like I said, it doesn't accept any arguments. So just passing in these values, passing in anything really should work. And we see that it does work. It returns the status code of 200, which is success, and the message that it's printing out for us. So that's in a nutshell, creating a Lambda in the console. Super easy, super straightforward. Now,
How fast are these lambdas?
pretty
Like how
fast.
fast does this thing spin up and then respond?
Let's see. Let's do an AWS list lambdas. Whoops. No, ls lambdas. Let's see. Oh, singular. I can never remember how to search
It,
these.
So like for example, I've got a app where one of my friends uploads pictures, some processing is done on them,
Hmm.
and currently that's done by an EC2, but the otherwise the app is very, very light, like nothing's going on really. A T3 micro could probably handle it just fine.
Hmm.
And I noticed the picture processing takes a little bit. So would the idea be I could keep the really low, cheap EC2 and instead pass off the picture processing to a Lambda that would spin up something much more powerful, do it, spin back down, and be more cost effective?
Right, exactly. So Lambdas would be pay per use, and really depending on the use case, it could be cheaper than running an EC2.
EC2, a EC2 capable of doing the processing quickly enough, but if it only does it like once a day, then it's probably you're getting overcharged for it, right?
Exactly,
Okay.
exactly. Let's see. Trying to find a very particular Lambda, the one that I just created. I don't want to scroll through all of these. So if I do um, AWS Lambda, get function name is demo Lambda. I cannot type. Function not found. Oh shoot, this was made in region 2. Okay, so it returns the lambda. So now let's call that using invoke function. Let's do that. Let's do this. It doesn't need a payload, or it needs a payload, but it could be empty. And we need to rename this to demo lambda. Okay, demo lambda. And let's also specify a region. I don't know if it's going to complain about this. Let's see, region US East 2. Yeah, let's see. Let's get that in there. Why is it not liking this? It's not treating this. Oh, it's converted everything to spaces. Damn. Let's just single line this then. And cool. So we've just invoked it super fast. It gave us the response. So when I say spin up, it's like you don't really even need to wait for an environment to spin up, right? That's how fast it is. Okay. Of course, as you add more logic, more complex logic, then we'll have to wait for that logic to execute. But lambdas are pretty powerful. They're very handy, they're very useful, and they're very quick to set up. So that's making a lambda inside of the console. But making it through your terminal is not as intuitive. So let's try to run through the demo on that. We would have to make our, oh, I hate how it does this. First, we'll have to make our script. So let's do a code main.py. We're going to just go ahead and going to we're going to write a function that accepts an event and returns a context. It's going to return a message saying transcribe is triggered. Now let's do a lambda, create function. Okay. Function name start transcribe. I wonder if it's actually gonna. It's gonna complain about these new lines. But let's see. Handler main dot handler. Uh, that has to, damn, that has to essentially line up with the method that you create. Oh, snap. What am I doing? Okay, and my account ID, as we saw it earlier, or maybe I can just grab it from here. No? Yes. Roll, shoot. I forgot what role I was using. Let's see. Maybe I have that saved somewhere. Okay. It's good. Should complain, doesn't like that. So let me look for a role to grab. Let's do, it's a lot of roles. Just do this. So role equals that. And now we could call that variable. Okay, so see, it's saying error parsing because having the script itself isn't enough. We have to zip that script up. And we'll also run into a few more things as we try to do that. So let's try to do that. Uh, Here, so first it complains because it wants it to be zipped. So let's go ahead and zip it. Where's the zip command?
Just below your highlighted text.
Ah, there it is. Simple enough. Lambda dot zip main dot py. Cool. And it's showing us how much it compressed. Now we'll also have to update the function to use that zipped file. So we do a lambda update function code. Function name is start transcribe, and we pass in the zip file. Cool. So now this should be callable. So let's go ahead and call it with invoke. And it doesn't require any kind of payload, so we should just be able to do this. Right, region. Uh, okay, cool. So it invoked the command. And if we do, right, if we open the response, this is what we see. Transcribe has been triggered, just like what our function says it's supposed to do. Now, doing this through Terraform is a little easier because one reason is we can zip up these files using a data block so we don't have to do it manually every time. Now, this, was fairly easy. We did this really fast. But let's say you're doing some more complex logic, then you would have to not only update the code each time, but you'd also have to update your packages, right? If you have like a virtual environment for this Python script, you would have to rezip all of that after updating your package files. Now with Terraform, let's do main.tf. Let's add this. Let's just add this first, actually. Let's add this first by itself. We'll also add a role. And let's see. Let's toss that in there and let's assume this role exists. And if it doesn't, it's going to complain. Terraform init. Cool. Terraform apply. Auto approve. Should have just done a plan first. Okay. Let's see what else is in this lab. Okay, so in this lab, we make multiple lambdas. So starting a transcription, checking job status, etc. All right. So, oh man, maybe this role just doesn't exist. Now, what did I use earlier? What should I use? Yeah, let's try one of these. So maybe instead of, well, actually, no. Well, what is this complaining about exactly?
You, I think it hard coded in there in main.tf lambda exec role.
Hmm.
That doesn't exist, right? In
Right.
that list of roles you just pulled up, I think it was a different one. Can you pull up that list again in
Yeah.
the terminal? Yeah, I think before you use the very first one, whatever that one was.
Okay. So let's try that. AI tutor. And it should just be this that we need. Let's see. Might be missing something. Okay. Let's try to create that resource. So it's saying that we need an AWS policy called Lambda Trust. And let's see. What do we need for these policies? Basically, these hmm, require a lot. So I'm gonna get some help from the GPT, complete this trust policy. Cool. Right. And I missed this, but we basically want to import an existing policy, not create one. So we're going to use data, save. Now let's try the auto approve again. Okay. Archive file has not been declared. So exactly, it's complaining because we haven't created the zip file yet. So let's go ahead and create that zip file. And we could do that with this data block that we saw earlier. Right. Cool. Here it is. Now, once we add this, we should be good. Terraform apply, auto approve. I've been adding new resource blocks. So I'm going to have to do a Terraform reinit. And now if I do my Terraform apply, it should finally be happy. Cool. And it is. It's showing these two outputs, a new Lambda and a role for that Lambda. And now it's going to complain because the role with this name already exists. And so let's maybe say two. This should not work. Okay, cool. That's essentially how you would create a Lambda through the console, through the CLI, and through Terraform. Okay. And we've been here for a little over an hour and a half. So run through the rest of today's lab on your own. It's fairly straightforward. It's just making a lot of these lambdas. It's a good way to get some muscle memory down on how to make these. Try to do it all from Terraform and your command line. And I will open up breakout rooms. We could take a quick break and then break for lunch around 12 and come back at 1. Stop there. Stop recording.